Hi students, in this video we are going to discuss about Z transform. Here this Z transform is used for the analysis of the discrete time sequence. We have already discussed about discrete time Fourier transform. It is also used to analyze the discrete time sequence. So the x of n is the discrete time sequence. Its DTFT pair is x of e power j omega. Similarly here x of n is the dt sequence and its Z transform is x of z. That is, instead of z e power j omega you are having z here, the same. It is both are similar. Okay, this is the DTFT formula. X of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n. So now Z transform is obtained. That is, it is both, I told both are similar. So just instead of e power j omega I am substituting z. So here the same, instead of this I am having z power minus n. If the Z transform is for both side negative and positive, it is said to be a bilateral transform. If it is only on one side, it is said to be an unilateral transform. Next one is we need to know about the region of convergence. Here, for any given sequence, the set of all values of z for which the Z transform convergence, that is, it attain a finite value, is called a region of convergence. Okay, so now I will explain this using some problems, then only you are able to understand this concept. Okay. Now here we are going to solve some problems and we are going to find the Z transform for the finite duration sequence. Considered here x of n is having this sequence. I need to find out the Z transform for this sequence. So you know the formula, that is x of z is equal to summation n is equal to minus infinity to infinity. Here it is that is from 0 to positive side. So I am taking from 0 to infinity x of n z power minus n. Okay, now here see this summation 0, index is 0, 1, 2, 3, 4. So here the index ranges from n is equal to 0 to 4, x of n z power minus n. Now you expand this summation, you will get x of 0 z power 0 plus x of 1 z power minus 1 plus x of 2 z power minus 2 plus x of 3 z power minus 3 plus x of 4 z power minus 4. So now substitute the sequence here. X of 0 is 1, z power 0 is 1, x of 1 is 2, z power minus 1 plus 3 z power minus 2 plus 4 z power minus 3 plus 7 z power minus 4. Now this is what your Z transform for the given sequence. Next we will see the next problem. Next x of n is equal to minus 2 minus 3 1 0 1. Okay, so here this value indicate the value at the origin. Now I need to find out the Z transform for this sequence. So x of z is equal to here, listen, before going to the next problem I will tell the region of convergence. Okay, so I will discuss about this region of convergence. So consider this problem. This is the sequence I am having. Okay, so this for which value the sequence will attain infinity. Now considered here, this I will write it here. So x of z, this is the continuation, x of z is equal to 1 by 2 by z plus 3 by z square plus 4 by z cube. You can write like this, 7 by z power 4. Yes, you can write like this. Okay, so for which value of z this should not converge. So when you substitute any value z, you have to check it. When you substitute z is equal to 0, this will become infinity. So at z is equal to 0, it become this x of z value does not converge and it will become infinity. It will not attain a finite value. So in this case, how we need to consider is, here the region of convergence is entire z plane except z is equal to 0. So like that you need to write it. So this is what the region of convergence for the previous problem. Okay, and now here consider the next problem. Here the same problem, here the same method. Here what I am going to do is, here it is 0, -1, -2, -3, -4. It ranges from -4 to 0, and x of n z power minus n. So when I expand this, I will get x of -4 z power plus 4, and x of -3 z power plus 3, and x of, so when you expand this, I will get this x by equation. Now substituting the values x of -4, I will get -2 z power 4 -3 z cube plus 1 z square. X of -1 is 0 and x of 1 is 1. So this is what the x of z I am getting like this. Okay. Now here, for which value we can have the z transform will not converge. If I substitute z is equal to 0, so I will get the value 1, right? Because when I substitute z is equal to 0, this term will get vanished, I will get 1. So now when I substitute z is equal to infinity, so what it will give, what the z x of z where the value is, it will become infinity. So here you need to write the region of convergence is entire z plane except z is equal to infinity. So like that you need to write down the, find out the region of convergence for this problem. Now consider this problem the same. Here we are having the both negative side and positive side, so I have written the summation from n is equal to -2 to +2 and x of n z power minus n. You know how to expand this. I have expanded this. After substituting the values, I am getting this sequence. Okay, so now see here. Now you see here we need to find the region of convergence. Okay, region of convergence. Here we need to find, here you are having both powers as positive as well as negative. Now if you are having the positive powers, so how will you find? If you put z is equal to infinity, the x of z value you will get it as infinity. Similarly, when z is equal to 0, for 0 also you will get the value infinity, that is the x of z will not converge for z is equal to infinity as well as z is equal to 0. So here the region of convergence is entire z plane except z is equal to 0 and z is equal to infinity. Okay, so here if you want to draw this region of convergence, how you need to draw this? So this is the real part of z and this is the imaginary part of z. Okay, so here the accepted z is equal to 0, so you need to draw a dot here. So the whole entire z plane except z is equal to 0, we may not able to draw infinity. Okay, so here you need to write region of convergence is z is equal to except z is equal to 0 and z is equal to minus infinity. Like that you need to draw it. Okay, so in the previous problem, how we need to draw the region of convergence is, here this is for the entire z plane except this is equal to 0. So here you can draw directly for all entire z plane, that is imaginary of z, this is real part of z except z is equal to 0, so you need to mark a dot like this. Okay, so that's what how to draw the region of convergence. Next we will see the next problem. Now see x of n is equal to del of n. So apply the formula summation n is here you will have only for value at n is equal to 0. So here x of n is z power minus n. So it is 1. Okay, when you substitute n is equal to 0 here, x of n is 1, z power 0 is 1. So here you will get x of z as infinity. So del of n z transform is 1. Okay, so now if you want to find the region of convergence, here there is no this x of z does not depend on any term z. So here the region that is the value converge for every value of z, it is taking a finite value 1. So here we this converge for all value of z. Okay, so that is the region of convergence is entire z plane. There is no except condition. Okay, the region of convergence is entire z plane. Previously and all it is depending upon z, so here we have written that region of convergence is region of convergence is entire z plane except z is equal to 0 and z is equal to infinity. Like that we will write it. Here there is no need to write it in this manner. Okay, now see x of n is equal to del of n minus k. So here you will get value of del of n at n is equal to k. So I am substituting n is equal to k here. There is no summation exists, only at one value. So here at n is equal to k, I am substituting for n. So I am getting z power minus k. So x of z can be written as 1 by z power k. Similarly, del of n plus k. So value exists at n is equal to minus k. So when I substitute z that n for n as minus k, I am getting z power k. Okay, so here if you want to find region of convergence, this value will attain finite for all value of z. Whatever you value of z you substitute, you will get some finite value. But at z is equal to 0, you will get infinite value. So the region of convergence is entire z plane except z is equal to 0. Okay, here for which value of z it will attain the sequence will not converge, that is it will attain infinite value when z is equal to infinity. Okay, so here the region of convergence is entire z plane except z is equal to infinity. Okay, so this is what about the finite, that is finding the region of convergence. So far what we have seen is we have seen for how to find z transform for the finite duration sequence. In the next video we will discuss about how to find z transform for the infinite duration sequence. Thank you.